Good morning and afternoon, everyone. We are Group 26, and our project is titled Counting Pattern in the Image. The team members are me, Sung Jian Yong, Celine Hu, Terence Tay, and Eugene Hao. The objective of this project is to develop a MATLAB-based image processing system that can automatically detect, separate, and count patterns accurately, even when the patterns have different color or overlap with each other. Now I will begin with the problem's background. In manufacturing and quality control environment, counting small objects such as buttons is often performed manually. This process can be slow, time-consuming, and prone to human error, especially when a large number of buttons need to be counted. There are three major challenges. First is the shadow and the background can cause to false detection. Second, the button come in different color and material, making them difficult to be detected using a single color channel. Third is the button may overlap or touch each other, causing multiple buttons to be appear as a single object. Therefore, our objective is to develop a image processing pipeline that can accurately detect and count buttons under this challenging condition. This slide shows the overall workflow of our system. The process begins with reading the input image and resizing to the standard size. Then the image is converted into a grayscale, HSV, and lab color space. Next, constraint enhancement and the noise filtering are applied to improve the image quality. Foreground segmentation is performed to separate the pattern from the background. After that, morphological operation is to clean the segmented image. If overlapping patterns are detected, watershed segmentation is applied to separate them. Finally, circle refinement is performed and the total number of patterns is calculated and displayed.
Thank you, Song. I'm Celine Hubunin. For this slide, I'll explain the overall methodology. First, the input image is read and resized into the processing is consistent. Then the image is converted into different color space such as grayscale, HSV, and LED. After that, enhancement and filtering are applied to reduce noise and improve the button edge. Next, foreground segmentation is used to separate the buttons from background. Morphological cleaning is then applied to remove small noise and fill holes. Finally, washout separation and circle detection are used to separate overlapping buttons and count them accurately. For these slides, this code use HSV and net color space to detect buttons. HSV helps detect colorful areas, while LED helps detect color strange. The white background is removed and different marks are combined to detect color, dark, white, and metallic buttons. And for these slides, this code separates overlapping buttons. It uses distance transform to find button centers, then applies Photoshop to split touching buttons. Hot circle detection is used to refine the result, so the final count is more accurate.
Thank you, Celine. I'm Eugene Hao. We're moving on to the output and results. The proposed MATLAB pipeline successfully detects and counts individual buttons from the input image. The process begins with the original image, followed by binary segmentation using HSV and LED color spaces. Morphological operations are then applied to generate a clean mask by removing noise and filling holes. Next, the watershed algorithm separates touching or overlapping buttons into individual regions. Finally, circle fitting is applied to each detected button, producing the final count and visual overlay. The result shows that the system can accurately identify and count buttons, including clustered and overlapping arrangement. In conclusion, the project successfully developed an image processing pipeline for automatic button detection and counting. The combination of HSV and LED color segmentation helped overcome the limitations of single-channel thresholding and enable detection of buttons with different colors and appearance. Furthermore, the distance transform and watershed algorithm effectively separated touching and overlapping buttons, while circle refitting improved the accuracy and visual verification of the detected objects. Overall, the system achieved its objective of accurately detecting and counting buttons from images. So these are the references used in our project, mainly official MATLAB documentation related to image processing techniques such as circle detection, watershed segmentation, contrast enhancement, and distance transform. These resources were used as guidance throughout the development and implementation of the proposed button counting system. Thank you. My teammate Terence will proceed to the demo.
So my name is Terence. Now I would like to show our demonstration for our project. Our project is the button counting using MATLAB. So first, we read the image first, and then we resize the image. This step is to standardize the image size, so it will have the same radius, and the morphology and the water setting behave consistently. Then we convert our RGB image to grayscale, SLV, and LAB. We are not only to convert to grayscale because the SSV help us to detect the color pattern, and the LAB separate the white background from the real object more obviously. Then we use the clad to enhance our weak edge and the low contrast boundary before segmentation and circle refinement. Then the next step is the filter noise. We combine the median and the Gaussian filtering to suppress the speckle noise whilst preserving the circular boundary. Then after that, the next step is do the background segmentation. We use the HSV and the LAB together, so the shadow and the white background are less likely to be detected as a button. After the segmentation, we convert the image to binary image. It let us to easier to do the calculation and the coding for later on. Then the next step is the morphology cleaning. We fill in the hole and remove the small object. It let us have a better mask cleaning with conservative morphology to avoid merging. Then the next step is we detect the connected component and we do the overlapping test and the distance calculation. We transform and local watch only on touching region. The overlap logic is applied per candidate block, not globally. Then after the waters, we do the final object filtering and the center refinement. We recalculate the center after the segmentation and refine each button circle. After that, we do the final display. We draw a circle label per one real pattern and add it actual center. Now is our result. So this is our original image. We use a button here, and then this is after the segmentation. If we have like this. Then we do the filtering and you will see the cleaning mask here. Then we use the watershed and to do the overlap separation. And last is our final result. It will see a circle label for each label here. And in this image, we have 20 patterns. That's all for me. Thank you.